Just wanted to give you guys an update on Willow. She had her surgery a couple days ago, and the poor girl is really sore right now. She's got a lot of bruising, but they said that would be normal. They put her leg bone, they put her hip socket back in. This whole bone was out of the socket, and so he got it back into the socket and reattached it. The ligaments had come loose, and the bone was cracked a little bit. We don't know how all this happened. She's never fallen or anything, but she is older. Maybe, I don't know, just jumping down a set of stairs or something, I don't know, but we lift her everywhere. But anyway, she's in pain and misery right now, but she's actually went through the surgery well. She's healing really well. Doctor seems pleased with what happened, so he said there's about an 80% chance this is going to work for her. Willow's on medical leave from Radio Hound 2 Radio Restorations right now, so right now I'm acting CEO of this. Willow, we got to get you back so we can not keep making mistakes. You got to keep me straight. All right, are you ready? Are you ready to Daddy to leave you off the video? All right, you be a good girl, okay? All right, thank you. Hi, welcome to Radio Hound Tube Radio Restorations YouTube channel. Today we're going to be working on continuing on the schematic, but for the people that say, hey, let's get on into the radio, this is the part that we do that with. We're going to be going and looking at the wiring section now. In the schematic, there's components. You have all the different symbols for the resistors and capacitors and coils, but all those things interconnect together with the wiring. And what we're going to be doing today is I'm going to start as if I was just getting the radio on the bench and kind of show you the steps that take place on a new radio that hits my bench. And I'll show you the first thing that I look at, and then we'll start actually physically working through that. And we'll just go as far as we can go today without boring you to death. And but as you're going to do this, you're going to see that, you're going to learn the schematic. It's going to help you to understand. Plus, you're also verifying some things in your radio that you need to verify, so we know that we can continue on with this restoration. Now, when I say restoration, I'm not talking about a level of a high-end level restoration. We're talking about putting all the electronics back to where they're going to last for many years to come. And then we're probably going to mess with the cabinet too. And I'm not a Frederick Taylor. I love his work. He's out in Texas, and he does phenomenal job on cabinets. But I respect his work and I follow his work. But I'm not even close to that level. But we are going to put the cabinet back in a lot better shape than it was. So when I say restoration, I mean at that level, at the beginner's level. We will work on this together. My goal with this channel is just to bring you somebody that knows nothing about electronics or about old radios, to bring you at least to the level where I'm at now. And I am not going to lie to you. I don't claim to be an expert. I've said that many times in the previous videos, but I'm going to continue saying this. This is a beginner. I'll say a novice that's teaching beginners on how to work on antique radios. If I say something, I've noticed a few things that I didn't even catch in the editing process, which is fine. I'm still learning how to correct it after I re-upload it to YouTube, which I haven't quite figured that out yet. But like the other day, I put up a video that is about when I went and picked up our second radio we're going to work on, and I called it a 12S262, and it's actually, I knew it was a 9S262, but I said 12S262, and I didn't catch that until after it went in and uploaded into YouTube. So I'm trying to figure out how to go in there. I know you can do it, I just got to learn how to go in there and put a little text over the top of that that lets you know that I know that's a 9S262. But I said 12S262, and I've seen a few things like that. I'm going to make mistakes like that, and I don't mind if you point them out to me, but most of the time I know that I said it wrong after the fact, and I'm just still learning how to use all the YouTube editing and the other editing that I use. I'm trying to get better at it to try to fix those things as we go. But if not, I'll mention them in the next video or something like that, and that way at least you know that I know. My goal is not to be an expert. My goal is to try to help you to become somebody that can relax and enjoy this hobby, because it's a fun hobby and it's an addictive hobby. If you're not careful, you're going to have a bunch of radios sitting in your garage. Don't go overboard. Just get the one, work on it, and then get the next one. That's the best way to do it. Okay, I hope you enjoyed today's video. It might be a little bit longer than normal. I don't know how it's going to work out, but you know, sometimes when you get started on this, it's hard to get to a quitting point. But we're going to get in here and I'll show you. All right, have a nice day. All right, before we start the actual wiring part, I want to get rid of these boxes that we have. So here's how I do it. You can do it however you want, but you got to just remember what you did. Now this particular box here, because you don't want this flopping all over the place where you're rotating this radio around. So what you want here is this side has 3 little plugs that pull out, but you want to make sure you identify these plugs, because you're going to have to be able to put them back in the right order. Now taking a video of it does help, because you got a black wire here, so you know the black one goes on that end. But these two are pretty much the same color, even though originally they weren't. But you know, we're going to have to mark these. So what I'm going to do is I'm going to get them marked, and I'm going to show you how I do that in just a second. Okay, the top, what you do is, it don't really matter which side you put top on. It's just you got to remember which side you're putting one on. So I always put a piece of, I use this blue painter's tape. I put a piece of tape on here. Now when I know which way to face this thing up, and then I know my number 1 starts on the top side. So then I numbered the panel that they're coming off of, 1, 2, and 3, and then I just numbered the wires 1, 2, 3, and then I can unplug it, and then I get it back real easy. I would encourage you, even if you're not going to video, I want you to take a lot of pictures, because you need to take a picture of that right there, so you know exactly how to put this back together. Because you think, well, I'll remember that. No, you won't, because you're going to be messing with 100 different wires under there, and if you're gone for work for a week or 2 or 3 days, you're not going to remember, I promise you. And you're going to try to think, well, how do I get that back together, because I can't remember where it went. Or you run into, you know, those situations where, you know, you have a wire come loose or a tag fall off. You have pictures of it to look back and say, okay, that's where that tag was, because these little tapes, sometimes they fall off, and then you can't remember where that wire went. So it's just good to take pictures as you go. Right now I'm videoing, so I'm good. So I'm gonna pull the wires on this one now. As we can see, we got this one off, and it's all ready to be put away in the box. And so I have a little rack, and I think I've showed you this before, but I set the bigger items on top. So that sits in here on top, and I know that's where that is. Now this next one is a whole different ball of string here, because this one, you really don't, it's hard to kind of figure out what is where if you're going to try to number it, okay? But we are going to figure out a way to number it. So first we'll get those marked, and then I'll show you how I did it. All right, so here's how I end up doing that. I put top right here, and I put it at the top of this and on this side, so I know where my numbering starts, and we're doing it just like you would be reading a book, left to right. But I also put it on the top side, so I know my top numbers are going to be on the top row, because if you actually look at this thing, you know it's a lot of wires. There's two rows, 2 physical rows of wire connecting points. So I'm going to cut these off, and I'm going to try to do this with the camera going, but I'm going to cut these off one at a time. So right over here is that first one on the top row, and when I cut that off and pull that little wire out, that should say 1, okay? So I'm going to cut right across that row, and then you'll be able to see a little bit better. Here comes number 2 off. And that should be my number 2 wire coming out. I'm going left to right. That's number 2. All right, and then number 3 is coming out. Put my tape right in the way of the cut. There we go, that's good. There's number 3 coming loose. And then number 4 is the one on the end. That's number 4 coming out. So those wires are all free. Now you can see a little bit better. Number 5 is right here. Okay, it's coming off. Number 6 is right there. Okay, now I'm on the second row now. I'm on the second row going left, right, and you'll see the rows a lot better when I get these wires out of the way. That's number 6, and then I named this one 6A because it's still on the same post, it's just on the right side. So I went ahead and named it 6A, and I know that'll tell me that's on that same post. Oops, sorry about the fingers in the way. And then my last one is number 7, and that's over here on the far right, and I'll cut that off. And that's number 7. So I got everything out of the way except for one left, and I named him what he is. It's a ground. So I put a G on there for ground, so I know that one goes back on the ground. Okay, now I'm going to try to hang on to this. Sorry, I got to get my hands in the way just for a second. I didn't want to drop that on the floor. Okay, so there's our other one off. So I know exactly how to put that back on now when we do it. Now I'll go in here and clean all these posts up. The little wires, all these wires here have to be replaced anyway. I'll be running up a whole new wire bank up here. And then right here, there's a bunch of wires on top of this that have to be replaced too, but I can see where they go from point to point. It's pretty easy to replace those on there, but you can see the 2 rows now. It makes it a little simpler to understand how this box is set up. When I got under here, I found they had this post, that post, and that post were all bent down and split to the right, so they were broke off. They weren't even making contact in here on these switches. So I'm gonna have to epoxy, because they broke the phenolic material right here when they were doing these switches. So I'm gonna epoxy in the back side of these. I bent these back up, and now I've got because these contacts down here weren't even making contact, they were turned totally sideways. So I'm going to epoxy those back into place before we put this thing back together. And that's probably how some of these buttons got broke, because they were trying to push them. But we'll find that out later. But here this one goes underneath there too, and these are out of my way now. So see, I can tuck those wires up out of the way. It'll be a while before we get to them. And now when I move this chassis around, it's not going to be as hard to work with. Plus I can do my cleaning a lot better. Okay, so what I'm going to do now is I'm going to get this chassis ready for us to start the second part that I do here. That'll be the first thing I do after I took that chassis out of the cabinet, is get those blocks out of my way. Back, I always put the chassis with the transformer side down, and the reason being is that thing is good and stable. It keeps your chassis from falling over. It gives you a good balance point, so you can rock this thing pretty good, and you're not going to knock something over, which I love. I got to get my lighting fixed here. Push this back a little bit. There we go. All right, because we got a lot of stuff to look at here. The next thing that I do, and I want you to just pretend, because I made up my mind, I'm not taking that speaker out of the cabinet until at the end here. But what I would have done, and we'll just pretend we did it, is I would have went out, I would have pulled that speaker out at least for a minute, and I would have tested this output transformer to make sure that the output transformer is right, that it has good continuity. And then what I do is I have a little booklet that I keep, and eventually this is going to be on a spreadsheet. But I always write down my output transformer. I write down the continuity of it, how many ohms it is. I write down my field coil that's on my speaker, how many ohms that field coil that sits right here. I write that down right here. I also have just started this, but it's a good idea. I had one of my collector guys, Scott, he told me to start putting the speaker number on it too. So I've been writing that down too. And then what I'll do next then with my little booklet is I'll start verifying my transformer. That's the first place I verified. Now technically, I know in previous videos we've already moved electrolytics and we've already checked all this, but we're going to do it again just to satisfy that need for us to do that. So what we're going to do is we're going to be looking right here at this transformer. What we're going to do is we're going to check our idea for what we're doing here is making sure that this transformer is good and the windings are good, because most of the time And we just had this happen. I'm working on that pilot radio for a customer, and I even verified the transformer, but for whatever reason this winding is shorted out now. And if you don't check this ahead, and what we end up having to do, he made the decision to go ahead and buy one. Transformers are not cheap. Now, for most radios, I would have a transformer in the garage that would probably work, because like a lot of these right here, I've got transformers like that all over the place in my garage, and they're standard size. But look at this radio. This has a big beefy transformer, and well, his radio was twice that size. His transformer, the one that was bad, was twice that size. And I did a whole bunch of work in the radio for him, and then after the fact found out that this winding was not right. So I either read it wrong or something happened while we were doing the recap on it. But bottom line is, you always want to check this, because he ended up spending, I think it was like 65 bucks he ended up spending it. They had $100 on it and he talked them down. But and the odds of finding that exact transformer was probably, I don't know, it was more than 100 to 1. I mean, it was the odds of getting that the exact transformer. He found the exact model and everything, so we're going to be able to move on with that project. But you want to check this really good when you first start. This is the #1 thing you check. And so we're going to check these windings again. So as you can see, we're going to check the high voltage winding. That's what these are, where it goes to the plates. That provides you know, around 600 to 650, maybe 690 volts AC to these plates right here. Okay, so these have to handle the high voltage, and you got to be able to do that, because you need that to rectify and make our high voltage DC coming out here. Remember how we learned in the class before. So we want to make sure this winding's good. So we know that it's coming into plates on this side, but it's coming into just one section, so that means that this one line is going to both plates. Okay, and I want to make sure I'm on, yeah, I'm on the right one. All right, so what it is we should see on this inside the radio, we should see one wire coming off that end of that coil that is going to both pins on one tube. So that means they're going to be tied together, whatever that pin number is and that pin number. And I told you on a previous video that you take your RCA book, and like I say, I've got my book set up to where it's, I had them done at a print shop where I took the book and kind of split it apart and had them make me a coil bound this way, so I can just flip right through and find what I need. So we're looking for our 6x5. And just while I'm on the subject, anytime you see that 6x5, they historically have problems with that particular rectifier tube. And I'm not going to go into all the issues that they have with that, but you can expect problems when you see a 6x5 anyway. And so I'm expecting when we fire this thing up, when we do a power up, we might have a problem with those rectifier tubes and have to get new ones. But we'll take that as it goes. That's not a big deal. And with the output transformer, I made a reference to that I said I'm not checking it right now. We're just going to pretend we did. The reason being is I got a bunch in the garage, and if we do have a bad one, then you know I can replace that. So we should be good there, even if it's bad. But I'm pretty sure the one we've got out there is pretty good, because I kind of pre-tested a little bit. But we'll cross that bridge when we get there. When I actually pull the speaker for the testing part of this, we'll test that output transformer and we'll put our numbers down. Okay, so I'm going to break here just for a second. I'm going to get this page opened up, and that way we can mark our schematic with our pin numbers, and that way we know what we're looking for inside the chassis right here. All right, this is a 6x5 in the book, and as you can see, it labels the pin numbers. So now we know, let me back off here and zoom in, I think it'd be better. Now we know that the plates up here, the anodes, okay, they're pins 3 and 5. So we can mark, let me zoom back out now a little bit. We can mark our plates right here, and we'll mark them 3 and 5. And the same way for this one, it's 3 and 5, okay? And as you can see, they're interconnected together, all right? So we know that that is what the plate is, okay? Now, we want to check we're going to be able to check this coil here too, because that's the filament to be able to turn these tubes on. So we need to check while we're in this book. We'll go ahead and get those numbers right here. So that's your filament is right here, and it's 2 and 7. Okay, so we're going to mark our filament 2 and 7. All right, so it's the one side and the other. Okay, so 2 or 7 is always going to be the one usually that goes to ground, and then this one's 2. So that's 7 and 2. All right, so that's our filament. So while we're in there, we might as well, you know, in the book, we might as well do that. So I'm going to move the book back out of our way now, and that helps us to do our calculations in here. All right, so now we gotta locate our rectifier tubes, and just since we'll just pretend you're just now tuning in, you missed the previous videos, but I'm going to lay this thing back, and I'm going to show you how you can tell what your tubes is. On Zenith, it makes it real easy, because on Zenith they put it right here on the tube, okay, that you got your 6x5G. Okay, so these two tubes are your 6x5. Okay, I don't know if I can get that good enough where you can see it, but all right, there you go. Anyway, this is going to be sorry, I got my hand in the way again. I haven't figured out, I got the new iPhone 17 and I did it for this so I could have it for this stuff here, but I haven't figured out all the camera angles and stuff on it. It's different than my 14, and so I'm still getting used to not having, so there's a camera right here on the, I got my hand, I'm not even in front of the camera, I've got my hand on the end of the phone, but you can see my hand. So this thing's got an awesome camera, it's picking up quite an angle. But bottom line is, okay, now that we know that on the bottom side here, these are our two tubes. Now, when you're first starting out, I suggest that you take a black marker and you go right in here on the chassis, and you just make your little room right there and write 6x5 beside that tube and that tube. That way you know when you're working underneath here, you won't forget which one's your 6x5. Okay, that's what I recommend you do. It'll write right on there. It's not going to hurt a thing to have that written underneath there. You would want to, if you're doing this for somebody else, make sure that they're okay with you marking the underside of their radio. But if you're doing it for yourself, it doesn't hurt a thing to have that 6x5. I mean, you can always wash it off with alcohol if you have to. All right, remember I told you how to count pins, okay? All right, we know that we're trying to look for our plates right now, okay? So our plate is 3 and 5. Now, if we go over here, we count from the little notch. See the little notch right there? That's your key, is what they call the key. And you still count the holes even if there's nothing in it, okay? So that right there is your pin 1. That one's your pin 2, and that's your pin 3. So that means somewhere between that pin right here, there should be a connection to pin 5. So there's pin 4 and pin 5. And look, there's a wire running right between 3 and 5. Okay, so we know that we can clip right onto that wire because it's going to get right in the middle between 3 and 5, and that's where we want to be because that's what it is on the schematic here. So we know where to put our first multimeter clip, okay? Now I've got these hooked alligator clips. My multimeter is hooked to the alligator clip, and so I can clip on to that little wire that runs between 3 and 5, and that's one side, okay? So to be able to check the other side of this continuity, where I want to see if I got continuity between here and here, all I got to do is clip on to the other tube because it just goes from one tube to the other tube, and that way I know this coil's good, okay? All right, so then all I got to do is get my other alligator clip, find my other tube that has the exact same wire that's going between 3 and 5. I don't know if you can see it up here because that capacitor is right in my way. Let me see if I can bend that guy out of the way. And these wires going across are in my way too, but oh well, we'll get it. See that wire right there? That's the other one that's going between 3 and 5. That's pin 1, 2, 3, and 4 and 5, okay? So we're going to go between those two pins right there, and we're going to clip on. All right, so now I got it clipped on both sides. So when I turn my fluke on, I should be able to see continuity here. And look, when you go in there, we have 170.5. So now what we're going to do is we're going to take our book right here, and we're going to put, this is because this is for our transformer. Now we're measuring the secondary here. I got all these lights in my way. Just give me a second. All right, there we go. I started off wrong and I had a big light right in my way. All right, so we're measuring the secondary because this side of the transformer is your primary side. This side is your secondary. So that's where I'm going to write that number right there. Is on the secondary side of that transformer is 170.5. Okay. All right, so that's what we're writing right there, 170.5. So now we know that this side is good, okay? Now what we want to do, now that we know that's good, now we want to make sure this center tap is good, okay? So our center tap right here, I'm trying to look through the camera and I'm messing myself up. All right, my center tap goes up here to the tail end of that, on the negative side of that electrolytic, and because that's your positive where your high voltage DC comes out. So this is your negative side, and this is, we already determined, was our electrolytic. So we go to the negative side of our electrolytic, that would be one end, and then all we got to do is keep the other end on this side on one tube. So all we got to do basically is hit the negative end of that first electrolytic. Well, remember we determined on our previous video that our electrolytic's coming out right here, okay? And we have two sides, three things coming out. We have two going in and one going out. And one is our negative. Our two electrolytics are going in. That's our high voltage DC going in on this side. There's one right there and one right there going in, but they both can combine inside there and come out as one wire to the negative side. And so one of these is our negative, all right? So all we gotta do is take this off. We take it off one of these tubes, leave it on the other one, and then we got to find which one's the negative over here, because that number should be, and I'm going to get this other light in here to try to help us. My gosh, I'm having trouble lighting. So dark and under this chassis. But anyway, we're going to find out where these three wires in, one of them is the negative. Well, we know it's not that one because the positive is coming straight off of the rectifier tube, so we know it's not that one. So we eliminate that one out of the picture already, and then we're pretty sure it's probably not this one here. So by a process of elimination, we're probably pretty sure that it might be that guy right there, but we're going to double check because it could be this guy too. So one of those two. So we're going to clip on, and whatever number we get here should be about half of that 170.5, because if we're at a center tap on this thing here, it should be half of that 175 that we got out of here, all right? So here we go. We should have half of 170.5, okay? And looky there, we got 82.7 when I clipped on. Now, it might be close. Just to confirm ourselves, we're going to go ahead and clip onto that other wire, okay? And we'll see what we get there. 45. So we know it's not that one. So we know that our center tap is that wire right there. At the bottom of this there's a terminal strip right here. I don't know if you can see in the camera, but it's the very last point on the terminal strip we know is our center tap. And so our center tap number is 82.8. Now, for the fun of it, we're going to leave that on the center tap. Oops, sorry. And we're going to go down and move from that top tube down to the bottom rectifier tube, and we're going to check the other side of that. Basically, we're moving from this tube to this tube, so we're checking this half of that coil to see if we, and I know we do, but we're going to get that number. Okay, see, this one says 88.9. The point I want to make to you here is you have two sides of this. You have 82.8 and 88.9. All right, and what you do is you you have disparity sometimes between where that center tap hits. And don't think that there's something wrong. That is totally fine. Now, if you had way out disparity, then that might be different. But if you see that, you're going to come, if you add those two together, you're going to come close to what we calculated on the 170.5. And so sometimes I'll just put it as a 1 because if it's close. But on this one, it's a little bit off, so I'm going to write the other number here, 88.9. And but what we did check out, and what I do when I get done with that, is I know for a fact that this winding is good, and I know that that's good up to right there. So I can go ahead and mark that and highlight that. We've already done that part of our radio. We know that that's ready. What makes me sad is on that pilot radio where we had the bad transformer, I had my schematic marked, which tells me I had good continuity through there, so I'm not quite sure what happened to our pilot radio. And that was a hard day when I found out that that was messed up. Okay, our next thing that we're going to check is the other one, the 2 and the 7. Because you have to check this winding and make sure this winding is good. Because if it don't, you're not going to heat your tubes and you're not going to be good. So we'll go back in here, and we already know it's 2 and 7 because when we went in our book, we added those numbers onto our thing. So now we're going to add back in here, and we're going to come back in here and see if we can find number 2 and number 7. All right, we're going to do it on this lower tube because I can see it better. So we know that our key is right here. We know the empty hole is 1, and so that's our number 2 right there. So I'll go ahead and hook one of my clips onto there. And I know this is real basic and simple for some people, but if you're just now getting into tube radios, you don't know. And so this is what I'm doing this for. My channel's for those people. So the people who don't know a thing about electronics, don't know a thing about, they just like the old radios. They're pretty, and they sure like to fix one. So the bottom line is I got that clipped onto 2, and then we count on around. That's 3. The empty hole's 4, 5. The empty hole's 6. And then this is number 7 right here. So we're on pin number 7 right there. So I'm going to clip on. Okay. Clip on to 2 and 7. Now, the thing you got to remember when you're dealing with filament wiring, you're not going to get big numbers like this, okay? And I forgot to write that 170.5 here. Okay, you're not going to get huge numbers on filaments. Matter of fact, you're going to get numbers like that. If you get a number like that and it don't say OL, then you're good. That's a good filament. That means you have continuity between there, and that's what you're going to get, a real low ohms rating on that. But that tells me, and I don't need to check the other one because look, I don't need to go to the other tube because this is all connected together. So if you got one, you got the other one because we're checking here and here, it's catching them all. So we know that that side's good, so we can mark that one as being ready for restoration. All right, so we can mark that. Now we're going to go in and look at the other filament windings because we have filaments going out to all these other tubes up here, and that comes out on this winding. And I think I said before, I'm going to move them wires out of my way. As I said before, on this particular winding, even though it's showing it on this side, these are all wrapped on top of each other. So it's really not on a side. It's just that iron core goes between this and that, all this stuff here. So I think they probably do that just for space on the schematic or whatever, but it doesn't matter. All you have to do is have it in the vicinity of this core because it's going to put out electrical field, and when it does that, creates an electromagnetic field, and it affects all these coils, and that's where it gets the voltage from. So this coil is for your filaments, and you see this little mark across here. This is a symbol for your light bulbs. This is your dash light or your dial lights that you have on your radio wherever they are. But what it's telling you is they are powered across this filament. When they say across, that means from that wire to that wire. So you have your one end of the coil, the other. That's where your filament is going to hook onto. I mean, your light bulbs are going to hook onto. One's going to hook on one side of this coil right here, and one's going to hook on the other, and that's what's going to power this bulb. And this is usually this winding right here is usually 6.3 volts. Okay, and this winding down here that does the rectifiers almost always is 5 volts. Okay, these are AC voltages. Everything in this transformer, until you leave this transformer, when you leave this transformer, it converts it to DC, this rectifier section. And then it converts it to DC, but everything inside here is AC voltage. So to keep that in mind, don't let that get mixed up. Remember, the AC and DC, it can survive both on the same line at the same time and do two different things. But on this particular area, this is all AC voltage that we're looking at. So make sure when you do your multimeter, I got an auto ranging multimeter. You can see where it says right there, auto range. But if you have a manual range, we want to have a class on how to do that someday. But right now, just get yourself an auto ranging, because it will auto do that. But you can swap between AC or DC. But bottom line, that's how we're getting that. So next thing we're going to check is the filament coming out here that's going to all these tubes. This is your filament winding. Now you understand, because it's filament, that's going to be a real low ohm again, okay? But let's try to find a place to do that. Now, every one of these tubes up here, every one of them, when that comes out of that little, lost my place here, over here. When that comes out of that little arrow right there, it goes in, the little arrow on each filament right here, it's feeding all these, and they're all wound in a series here. So we can find out where that comes out at the chassis, or you can just go, which is easier, go to one of the tubes and find the pin numbers for that tubes, okay? So you would go to your book. Let's just pick this tube guy right here, because we can see him real well, okay? And let's find out what tube that is, so we can lay this chassis back. I'm gonna show you an easier way to do this later on, but right now I'm just showing you this because Zenith has its own numbering system. But this tube right here, whoops, I'm too focused in now, or zoomed in. All right, now we're gonna pull this off. Uh-oh. Let's pick a different tube, because that tube is hard to get. Let's pull this one. Okay, this tube's coming out. It don't matter which tube, because all the rest of these tubes beside the rectifiers are hooked on that same series. Now you notice when I'm pulling this tube, you have to wiggle it in a circle, because if not, you're gonna rip that envelope right off of there. And these things are rusted in, and they're needing repaired really bad. So I'm going in a rotation, like, I don't know if you can tell, I'm rotating it like that, but I'm pulling while I'm doing it. And eventually they'll work their way out, but it takes a little bit of a fight sometimes to win, and hard to do it one-handed too, because I can hold the chassis still if I, let me try this. There. All right, that was a workout. All right, so now we can see on top that this is a 6J5. Now hopefully there's not a lot of stuff in our way underneath here on this particular tube. That way we can get to it. Yeah, it's not bad. All right, so that up there on the bottom side is the 6J5. You can bend this stuff out of your way, just don't break it off. But all right, now let me get my pointer back, and we're gonna go to the book now, and we're gonna look at the 6J5. Now, on a lot of these radios, especially Zenith, they like the 6J5, okay? So they use it in a lot of parts of the radio. The parts that they use it as a detector tube. We told you on a previous video what that detector tube does. We'll go into more depth as we work our way across, but bottom line is you have a 6J5 there. I don't know if there's any more 6J5s in this radio. I'm looking real quick. Yeah, there's an inverter tube. It's a 6J5. So it's going to be one of these two tubes. Bottom line is the 6J5, once you look at it in the book, it's going to have the numbering system the same on each one. So when you flip over here, we just got to roll back to the 6J5 and 6J7. These are all in numerical order, so it just have to kind of like alphabetical, only numerical. So, and there's a 6J5. Okay, so now we're looking for the filament, and the filament windings is the same as our rectifier, 2 and 7. Okay, so we're just going to mark that on both of our 6J5s over here. So when we get to our 6J5, we know that is 7, or excuse me, that is 7 and that is 2. All right, and then we'll mark our other one. So that is 7, or 2, I mean, and that is 7. All right, so now we've got those marked. we're going to come up here to our radio, and we're going to count our pins now, okay? So our little notch, I got to get you, we're in your camera shot. Our little notch is right there. So pin number 1 is right here, and pin number 2 is right there, okay? So let me get a better light in there, maybe you can see. That's pin 1 and that's pin 2, okay? All right, now we're going to clip on, I'll clip on to pin 2 right there. All right, and then our other one clips on up here to pin 7. So we're going to count all the way around, and that's 3, empty hole 4, 5, empty hole 6, and then there's 7 right there, okay? So we'll clip on to 7, all right? If we clip on any one of these tubes, what we're doing now, when we clip on to any one of the filament windings on these tubes, if we clip on there, we're clipping across here. You're clipping across exactly across what's down here on the schematic. You're clipping between here and here because they're all across each other. All right, so if we get continuity here on any tube, then we know it's going to be good. And look, we've got our continuity. And that's kind of what you should expect, 1.2, 1.4, 1.0. Most of the time you'll see that on the filaments if they're good. So now what we answered for ourselves here is we answered not only this filament good, but we also know we're going to have dialights on this thing. Dialights are going to work unless the bulbs are burnt out. They're going to work, so we've already answered that for us too. So the only thing left on the transformer to check out is the primary winding. This is where the plug comes in the door, okay? Well, as you know me, I'll cut that sucker off, and I did. I cut it off right there. So, but what I do is I try to find where those 2 wires come in, because that's the important part, okay? One will go in straight to the transformer, and the other one will go in, and before it gets to the transformer, it'll wind up here, and it'll go up to the power switch where it turns it on. So you see it winding up there, all right? And then the other cord coming back, that's winding back to the transformer. So what we want to do, we're checking the coil here right now. We're not checking the switch, we're checking the coil. So we want to clip on to where it comes back out of that switch, not where it goes in. And we saw the black line is where it goes in. That black wire is where it goes in. So that means the striped wire is where it's going to go back in the transformer. So we clip on right there. All right, then we grab our other clip, and our other clip's got to get on the other side. So it's going to go, we already clipped on, my gosh, I'm moving all over the place. We already clipped onto the switch side. Now we got to clip onto the one that's going straight into the transformer. See what's just going straight into the coil? So that one is just easy because we can clip on right here where it comes in the back door, right there, all right? So I got one clipped on where it goes straight into the transformer off of one of these wires on the negative side. On the positive side, I'm clipping on the return from the switch, and that way I'm only checking the coil. I'm not checking the switch yet, okay? All right, and then when I look over here, it should be a number, like I said on previous videos, like sometimes it gets up close to 20, but usually it'd be, yeah, anywhere from 4 or 5 ohms all the way up to less than 20 probably. All right, but that's what you're looking for. So we know that our primary, and I put it on my little paper, my primary is 5.7. I also write down here 5.7. That way I know on my schematic. The other thing I know, other than the switch, I know my winding's good, okay? So now I'm going to check my switch. Now the only way to, or the easy way to check that is just move to the other side. You move on the switch, you move to the incoming side now, okay? And then what we do, and I hope I can do this without knobs on, but I got to figure out which one it is. Not that one. Probably should have prefigured this, but let me get my... Without knobs, you got these little tiny thing here, and it's nothing that is hard to hang on to. There's my switch. I don't know if you heard it. I got a little pair of pliers on here to help us. You hear that click? Okay, that's what we want to look at. Now, what we want to look is over here, and when we turn it on, we should get something. And look at there. Oh boy. So guess what? we got issues with this switch. That's not good. This could be a cleaning issue, but as I'm turning it on and off, I'm not getting it right. When I turn it on, I should be getting continuity through there to that transformer, and it's trying. You can see where it's trying, but something is not working right there. So we'll have to look at that. I'll probably have to end up removing that switch and see if I can clean it real good, because this is not going to be an easy switch to replace, because it hooks into all this other stuff that is fun to work with. So trying to find a switch that is short enough, it's going to have a real short, because you have to pull that, the stubby goes up in here, and you have to pull this thing off and then get the switch out. But we'll try to clean it first, because it looks like it's trying to work, and I might be able to just take and spray down in this back. We have this powerful spray here that works good. I get this, well, I used to get it at O'Reilly's. I think I have to go to AutoZone now and get it. It's expensive. You can get it online too, a lot cheaper, but I'm not a big online guy. But I like supporting my local people. But you can do whatever you want on that. All right. Bottom line, we know now we got everything good except for this. Now what I do is, when I find something like that, I will mark it. Okay, we got the wire coming in the switch good, that wire's good, that wire's good, everything's good, but my switch is got a problem, okay? And so that'll identify that I need to come back to that. So I'll take a different highlighter, and all my problems, I'm moving this camera around like crazy. I tried to hold on a tripod, but you can't get in where you need to get, and it messes me up. So I just rather you guys deal with all the shakiness for a while. Okay, and I marked my switch green, and that way I know to come back to that. I'm going to have to visit that, okay? Other than that, though, today we're checking coils, so I don't really have to worry about that. Now, we're going to pretend also, because, like I say, I'm not going to pull that speaker right now. Let's pretend, but you do need to do this up front. You need to know this, because this is the second no-go. If your transformer's out of whack, you might want to decide, is this radio worth the money to buy a $100 transformer? Then the second thing is, sometimes a no-go is a field coil. If that field coil that's on the speaker up here, that field coil right there, if that thing is bad, oh, that thing just fell off. Oh, okay, I'll have to get the coating on it fell off. But anyway, if that's bad, sometimes that's a no-go, because those are hard to find, and they have to match. Everything has to match up, because this field coil, remember, it does filtering. It also drops the voltage right, so it matches into what you need here. So you can't just throw any old field coil, and this one says 670 ohms. So that's another reason I'm not going to go measure that right now, but we should be close to 670 when I go measure that. But let's pretend we did, and that's good. If not, I've got a backup speaker that we can use on this radio, so I'm not too worried about on this particular radio. But yes, that is something you need to do, is measure that field coil, and then write that in your little book here. Write it in there. And if you got a spreadsheet, and eventually that's what I'm going to do. I just haven't. I've got a whole book full of these. But what it does, it'll help you later on when you're doing your next radio with this model. You know what you should expect to see on these, especially when you fire it up. I put the milliamps and the watts when that thing's running at idle, where, you know, when you actually get it up and full running, then you know how many milliamps and watts it should pull. So if it's pulling too many watts, you know something's wrong, or something you did wrong, or whatever. It helps you to identify that. And eventually I'll have an evening where I can sit down and get all this put into a spreadsheet. But until then, I got my little books, and I do everything by hand anyway. I don't know why. Just the way I like to do it. All right, so our next coil, and we're going to pretend that like I say, this is our output transformer that's out on the speaker. We're going to pretend that that's good, okay? And we're going to pretend our field coil is good, because that's the next ones you would check. You would check your speaker and your field coil. And you see I'm working my way out from the transformer, okay? All right, now our next thing that we're going to check, and I don't know if I have time. I probably need to do this on the next video, but we'll do this on the next video. But we're going to check our output our IF cans. Remember we talked about our IF section where it converts that modulated wave carrier wave. It converts it down to 455. That's what this radio asks for, is 455 right there. And most of the time you'll find that IF frequency there, but it'll modify it down. Well, we have to make sure these coils are good. There's 4 coils, 1, 2, 3, 4, and each of the 4 coils are in the 2 cans. There's 2 in each can, and the cans, when I say cans, I'm talking about these metal boxes that sits on top. Well, there's 2 of them sits up there, and there's 2 coils in each can, and we have to make sure that those are good. So we'll do that on the following video. So I hope you enjoyed today. I hope it kind of give you an idea on how to clip on to be able to verify this kind of stuff. And it's really not that hard. They call this point-to-point wiring. Unlike like on circuit board wiring, you have traces, and basically it's wiring is all it is. It's just they have a little copper trace that goes between those 2 points, and when you clip your little transistor or whatever you clip into that circuit board, the legs of it touch a trace, and that trace goes to the next item. Well, that's all we're doing here, and that's all we're doing here. What I'm teaching you now is we taught about the parts, and we're teaching about, you know, all the symbols for the different items, but now we're teaching you about just the wire that's going between point A and point B. We want to make sure we got continuity, and that's the same here. That's a little wire that's going between this point and that point. Well, we're just making sure that that wire is not broken or shorted to something. Like it could be, if it's broken and open, you'll get an open symbol. It'll be an OL over there. Sometimes if it's shorted, you'll get a real high resistance rating, or you get something like that, because it might be shorted to the frame here. It might have burnt through and shorted to one of these other windings, you know. And if it does, you get this real high ohms resistant rating a lot of times, and it'll be some weird rating, because you know after a while you get used to this high voltage winding being between, you know, like we had 170.5 here, but usually no more than about 500 ohms, you know. It's not much, but if you get 3,000 ohms across here, you know that you got something that's shorted out in there. All right, so bottom line, that's what we're doing on this next series, is we're checking that. We're verifying that wire between point A and point B where there's nothing in between, okay? And that's kind of what this part is. So now we're checking our coils. The next video, and it won't be, like say I'm doing these videos, let me do one a week. The next one, we're doing these 2 IF cans, we're checking those coils. So hope you stay with us. Enjoy. Thank you. Well, I hope you enjoyed today's video. A lot of information there, and I hope that it'll help you. The more that we can get in here and start matching that schematic to the actual radio that's back here, I think it'll help you to feel way more comfortable with dealing with these schematics. And when you need to have that comfort with the schematics, because when you get into the troubleshooting phase, that's where it's going to come in handy. When you run into a radio and it's making some weird noise, you need to know how to read a schematic so you can figure out what's going on. So I hope that each day that we work on this, I'll be uploading, I think, about once a week right now until I get better at it. But I hope that you know, you'll just come along with us and enjoy. Please like and subscribe, and we'll see you on the next one. Thank you.